Welcome back to Ergstown, 4th grade scientists. We are in lesson 2.2 today, activity 4, synthesizing ideas from the book. Let's start by reviewing our unit question. The question we're trying to answer for our entire unit, energy conversions, is how does the electrical system work? The chapter we're in is chapter 2, and the question for this chapter we're trying to answer is what makes the devices in Ergstown output energy or fail to output energy? So what makes them actually output some energy or make them not work? That's what we're trying to figure out. Today specifically, we're working on this question. We've been working on it for a couple days now, so hopefully you have some understanding. How do devices have so many different output energy forms when they are plugged into the same electrical system? How can you get motion when you're plugged into the electrical outlet? How can you get sound when you're plugged into that same electrical outlet? So today, we're going to use page 28 in our investigation notebook to help us synthesize information from the different parts of the book that we've read. So if you haven't completed activity 3, which is the book being read to you, you need to stop right now and go back to activity 3 and read the book with me. If you have, make sure you pull out that investigation notebook and open to page 28. To begin, we're going to do some of this together. So we need to reread some of the pages from the reference book. And we're going to read page 6. As we're reading, I want you to see if you can find any ideas that will help us answer our question about electrical devices. Keeping cool today. People tend to use more electrical energy on hot days than on cold days. To keep cool when it's hot, people run electric fans and air conditioners. These devices use lots of electrical energy. Here's how an electric fan works. Wires transfer electrical energy from a power plant to the fan in your house. The fan converts electrical energy into the motion energy of the spinning blades. The spinning blades of the fan transfer motion energy to the air, creating a breeze that cools your skin. So if I'm going back to look at this, I'm going to see that the fan converts, moving my cursor over it, converts electrical energy into motion energy of the spinning blades. Do you think that example will help us answer the question about electrical devices? Let's go back. Let's look at this question. How do devices have so many different output energy forms when they're plugged into the same electrical device? Well, personally, I think seeing that a fan converts electrical energy into motion energy is a great idea. So I think you should record it in your graphic organizer on page 28. Now, if you don't have your page 28, you can find it in your seesaw assignment. So our first idea, an idea that we're going to use to help us come up with a new understanding, is that fans convert electrical energy into motion energy. And we found that on page 6. So please write that down. We're going to read page 7 together as well. Keeping cool in ancient Egypt. Kings and queens in ancient Egypt also used fans to stay cool. However, these fans weren't electric. To create a cool breeze, a servant moved a feather fan up and down. Motion energy was transferred from the servant's arms to the fan, and from the fan to the air. Unfortunately, the fan's breeze only cooled the king or queen. The servant stayed hot. Oh my goodness. Now, as I was reading, I read that the servant moved the feather, so and motion energy was transferred from the servant's arms to the fan. What I'm hearing in that is that the servant's body converted energy from their arms to the fan. Their body did. Now, our question, if you remember, asks about electrical devices. Was there any electricity in this paragraph? Was anything plugged in? Was the servant's body plugged into an outlet? No, we can't plug in a human body. So does this page help us answer our question about electrical devices? If you said no, you're right, because you can't plug your body into an electrical system. So here's what I want you to do. Go back to video from activity 3 and listen to it again. And as you're listening, I want you to find 3 more ideas that talk about converting energy, electrical energy, into another type of energy. It doesn't have to be motion energy like our fan example was. So you're going to find 3 more ideas, and then we're going to use that information to get a new understanding. Here's how I'm going to help you do that. Remember, the question you're trying to solve is how do devices have so many different output energy forms when they're plugged into the same electrical system? You need to find examples in the reference book. You're going to then synthesize those ideas that you've written down to answer the question, how do devices have so many different output energy forms when they're plugged into the same electrical system? I know you hear me say this over and over again, but that is what you're trying to answer. Here's a couple questions that can help you answer our big question, our new idea. I've also written these in Seesaw, and I want you to answer them as you're going along. So what do we know about forms of energy? Take some notes about that. And what do we now know about electrical devices? Remember to use the word convert when you are trying to answer that question. It converted from electrical energy to motion energy. I'm thinking of the fan. Use those to help you. And then, once you've done that and written all your ideas, I want you to synthesize or come to a new understanding by taking all the information that you've read, all the ideas you've written down, and you're going to connect them together to answer the question. And you write down your new understanding. I can't wait to read them, and I'll see you in the next video.